All right. We should actually be live. Let me just check. How does this look? And then we will begin. Not seeing anything yet, but maybe soon. If you can write in the chat, you can see the stream. Yeah. All right, now I can see it myself, so let's begin. So, welcome to the first Finland Azure User Group Tips and Tricks stream of 2021. Very exciting. I seem to be getting some errors in the stream, but please write in the chat if it's still a problem. But let me switch to the slides and start. So, Finland Azure User Group. You probably know what it is. So, these tips and tricks sessions are basically roughly 30-minute streams of one person from the community showing something they have worked with recently, something new they have learned. This stream might be a bit longer than 1 hour, but let's see, or at least longer than 30 minutes, but let's see how long this takes. Basically, Finland Azure User Group has over 1.7k users right now, members, and if you want to join, you can go to Meetup or Google just FAUG Meetup to find the community site. And today, our presentation is on Bicep and checking out these guns. These are always guns, not mine, but hopefully you'll get the point. I'm Pasi Huuhka. I'm a DevOps architect working at Azure. I'm also an Azure MVP, and I've been working on Azure since roughly 2014, on and off. And I've helped to develop and automate applications on Azure for 40 plus customers at least. I just looked at some stats, and in the last 2 years I've worked with 32 customers, so I think it's a bit over than that right now. There's my Twitter. I also write a blog semi-seldom nowadays, and there's some extra links there also. Some of them are actually old. Let's move forward. Azure is a purely Azure company. We only do Azure with a focus on platform as a service. We have 65 people in the company, and 60 of them are experts. We also have 4 Azure MVPs and 2 offices, and many of our people are very experienced in Azure and in development in general. We have 2 offices, one in Finland, one in Ghent. But that's enough about Azure. Let's take a look at the session itself. So we will take a look at what Bicep is, why I am talking about it, and so on. We have a lot of demos, so a lot of this session will be going through code. Hopefully not too quick for you guys, but if it's too quick, you can always go back to the pod. We have some demos, we have some questions, and also information on how to find more information. Yeah, it seems we have some jitter in the network, but there's nothing I can do to fix it right now, so let's hope this works. But yeah, Bicep. It's the next generation of Azure Infra as a code. And what is it really? So, like the image shows, it's really a language on top of ARM templates. So there's a CLI which you can use to build your Bicep language files into ARM templates. So basically it's just a layer on top of them. Anything that works with ARM will work with Bicep. and pretty much vice versa at the moment. And the idea, which we'll take a look at soon, is to make ARM template development or development on Azure as infra as code a little bit easier than it has been with ARM templates. And when we do run AZ deployment create, we basically deploy the ARM template that has been created by Bicep to the Azure Resource Manager APIs. And then, just like with ARM, the resource providers will take over here. The goals for Microsoft have been to reduce current pain with ARM template development. It was JSON, so basically it's not very human readable. Bicep is a lot more human readable. Then the idea is to also lower the barrier to entry. So both of these go pretty much hand in hand. We also get some transparent abstraction, so it's a lot easier to point to some existing resource, for example, or one resource that you have specified before. And also it takes the modularity that was provided with link templates in ARM one step further with this module kind of functionality here. But the non-goals were to actually not have one language to rule them all, which is why Microsoft decided that they actually want to have something on top of ARM and not just replace ARM altogether. So if somebody wants, they can just write a better version of Bicep or whatever on top of ARM if they want. And also, it's not a general purpose language to meet any need. And how I interpret this is that basically, if you compare to Terraform, for example, Terraform can do something that's inside a Kubernetes cluster or inside a VM. ARM or Bicep don't really necessarily want to do that, or it's not their main focus. Their main focus is the platform level resource creation. Of course, you can do that if you want with, let's say, deployment scripts to configure a VM completely. And, well, inventing new technology also goes back to not replacing ARM necessarily. Version history for Bicep, well, 0.1, it's been like half a year since this came out. It's had some basic stuff, but was not really usable. Really, it had the auto depends on, but I wouldn't recommend that you'd have used Bicep in 0.1. Then a couple of months ago, we got 0.2, which had IntelliSense modules, code formatting, and scopes, which already pushed Bicep into a level that most projects, at least in my mind, could have used it. And now, since last week, 0.3 is live, which means that there's parity with ARM templates, with loops and conditionals also added. So anything you can do with ARM templates, you can do with Bicep also. With some caveats, of course, but perhaps we'll take a look at those in a bit. It has also been integrated with AZ CLI and PowerShell. So you don't necessarily need to have the Bicep CLI separately any longer with 0.3, but at least for Azure DevOps, for example, I don't know if this has yet been updated, so I don't yet use CLI or PowerShell with Bicep myself there. You can also decompile your ARM templates into Bicep, so basically go the other direction. I'll show that in a second. And one big thing also is that 0.3 is now production ready, so basically you can ask Microsoft for help if you need it for Bicep. So, as I mentioned, let's take a look at some demos here. And this will be most of what we'll be doing. So, first of all, my notes here. So, installation and extension. So, as I mentioned, you can just install the newest version of AZ CLI, which would be, let's say, AZ upgrade. You can do all to upgrade your extensions also. And also you can install your newest PowerShell version to get it. Then you also need an extension, or you don't necessarily need it, but you really do want it. And it's just named Bicep here in VS Code. It's the one by Microsoft. Pretty simple. Once you have installed it, you can just do, let's say, AZ Bicep. I think there is help. This works. We can maybe do version like so to get the newest version, but clearly some things here don't quite work just yet, unless I'm doing something wrong. I had to run the Bicep AZ Bicep install for this to work completely. You can also install this from the repository directly if you want. So I have both installed here. So if I do Bicep version, I get the 0.3.1 there. But that's about it. Now you can do Bicep. Simple as that. And it's quite similar in your CICD pipelines also. But let's start coding. So first, let's create the most simple resource we can have. So our storage accounts, it's always in these demos. So how the Bicep syntax works is that we define a resource first. So the IntelliSense already gives us some good suggestions on how to get started. But I often just go with resource. Then the next thing we need to give is an identifier. So this can be anything you want, just basically an ID for this resource. So we do a storage account, let's do just storage, for example. Then the next thing is to give a type identifier and an API version. And as we can see already, without any suggestions, it does try to give you a list of things to do here. But we do need a storage account, and I often try to not use the preview API version, so let's take the second one. And directly we can see that compared to ARM, we have the API version and the type here on the same row, saving some space. Then we do an equals sign, and again, our IntelliSense gives us either a for loop or just a normal resource here. So we immediately get some squiggly lines. It's telling us that it's knowing that we need a name and a location and an SKU. So let's just start writing something. So if we take an IntelliSense look here, we can give a name to our storage account. This could be something like that. We need a location. It can be West Europe. We need a kind. It automatically knows what can I fill in kind. This does kind of differ between different resource providers. Some, like the storage account, give almost everything to you, but some don't really give you suggestions. Then we could do an SKU. It knows that we need a name. This could be some LRS. We need a tier also. This could be standard, and we don't need anything else there. And last thing, let's add some properties here. For example, HTTPS traffic forcing, and maybe an access tier also. So as we can see, we can get hot and cool. So there's our hard-coded storage account. Of course, this is not something that you do in production, but we'll build from this. Then we have parameters, variables, and outputs. So unlike in ARM templates, we actually can do parameters, variables, and outputs anywhere in this file. So in ARM templates, you need to have parameters and variables at the top. So here, if I wanted to, I could just start writing parameters here. So in Bicep, it's param. We have some examples here by the IntelliSense again, but I often just do this. And then next, we need an identifier again. So this could be something like storage name. We get the same types that we get in ARM templates. So this would be a string, and we could do a default value here. So let's just copy this here, and I would just based like that. So when compared to ARM templates, this would be like something like parameters.storage name, really. What this means is that as we have variables and parameters, they cannot have the same kind of identifier inside the same file, because we don't point to either parameters dot or variables, so it wouldn't know how to configure this. But I think that placing parameters after the resource that uses them is kind of blasphemy, so let's move this up here and start working on it. So what else could we do? If we had some password, we do secure string here. So this doesn't show up in any logs, just like in ARM. But here we actually do get some more options. So if we need to add any options to our parameters, we can do this kind of object here and add either allowed, what are the allowed values, what's the default value, max length, metadata, and minimum length. Of course, just like in ARM nowadays, you can just add comments here, so you don't need to really use the metadata. But this is something that you could do for secure strings. Then variables, we have again a template here. This could be something like, what do we want? Let's do addition, so just some normal numbers. So basically, you don't need to specify what is the type of this variable, and yeah, we can also see that in Bicep you can just do 5 plus 2, for example, here. Let's do another, and a location. This could be something like West Europe. I'll be using this a lot, so it's good to do as a variable here. So there we go. And lastly, just like in our templates, we have outputs. So let's see how this works. So we would maybe want to output the name of the storage, and this could be a string. So this should work. And here we can just do storage.name. And as we can see, by doing dot, we can get the identity, ID, kind, location, API version, and all this stuff from the actual object named storage, which is this. So let's do something like account here, so it's a bit more clear what this means. So here's a full resource, really. And this kind of what I've been doing with Bicep is trying to place at least the outputs that I'm doing very close to the resource itself. Same goes with the variables. So with ARM templates, outputs would always be at the very bottom of the file itself, but I think it's a bit clearer to have these near their context. Then let's see what else. So ternary clauses and expressions. So one expression we already had here, but as it turns out, we can actually do ternary clauses also and other expressions. So I'm just gonna take out this password so we can deploy this at some point. I don't want to give in a password that's not used, but let's give in an environment, for example, and this is a string and it can be dev. So if I wanted to do something based on this dev, I could first of all do something like environment equals dev, and then do a normal ternary clause. So if it's true, let's do storage name, and if it's false, let's do something like some hardcoded name. So these things that you have from general purpose programming languages, you can do here also. And this could be many things, so not equals to larger than, or something like this. And if we take a look at how this actually builds in, what does this build into? We can do az bicep /f, and actually it's build/f, and this is something like storage.bicep. So hopefully we build, and we have the storage.json here with the same name as my bicep. And as we can see, for example, for the addition that we looked at, it automatically kind of compiles it to the function that ARM uses in the backend. And same goes with this if equals dev parameter storage and so on. So it's just kind of a simple way to write things. And also for the outputs, we can see that in our bicep file, we only have storage account.name. So this can be something, whatever you want, and you don't need to make the change into your outputs any longer, because this kind of knows how to get the value from this field directly. But as we can see in the ARM templates, this is just the same string here duplicated. So this will help with maintenance also. Then next up, one more thing, there are many of these expressions, and you can take a look at the documentation for most of them. But this is actually probably the first thing that you will be using is equals. Then I don't have it listed here, but next thing would probably be something like conditions. So we can do conditions with if here. So basically, if we do if after this equals, we can do that if env equals dev, and this equals to condition in ARM. So if the environment is not development here, then we don't actually deploy the storage account at all. So this is quite a lot simpler also, in my mind at least, to read than having the condition field here. It just pops out a little bit better in my mind if it's here color coded differently. The next thing, storage arrays. So how about deploying multiple storage accounts? So just like in ARM templates, really, we can do storage accounts, and as this can be an array, let's do an array of storage accounts, and this could be something like 1, and then let's do 2, 3, 4. So now we have a list of storage accounts that we want to deploy, or at least storage account names at the moment. And how this would work is, if my intelligence works, let's do storage copy as the identifier. This is again storage account, and after the equals, we can do the for. So this is a for loop, and just in any other language really, you can do item in list. I should be back live. Let's hope this works better. I'll try to focus on this, but again, thanks Yuri for pinging me. I did not know this. Let's hope this works. So we had 4 item in list. Yeah, good. So for item in list, so earlier we had, let's actually just go backwards here. We were probably somewhere here. So basically we had account in storage accounts, and we did account for the names of the accounts themselves. So we could also do just objects here in my variable. So I start writing. I can do location. I could also do something like name for the SKU and a tier. And I could copy it and create another one and change into ZRS for the secondary one. And now that I have that going, the changes I can do in my storage account copy is I can do account.name. So while I don't get any intelligence for these kind of variable pointers here, I often do know what's inside my variable, so I can easily do account.location and then just replace the whole SKU part here for the D. Let me still check if I'm dropping frames. No, everything seems to be good now. Let's hope that fixed it. But yeah, this could be account.sku. And now that I deployed this, I could have just run the Bicep build for my storage.bicep, but I can also just run my new AZ resource group deployment command to my storage account or my resource group, and then do the template file here with just .bicep. And as we can see, we actually did get 2 storage accounts here. Hopefully we actually get 3 because there's 1, but we got the 1 and 2 with this loop. So next up, how do we actually get outputs from this array? It's fairly simple. So we just do output. This could be something like storage IDs, and it's an array. And again, while I don't think I get the 4 here, I can just write it out. So this could be for account in. You could do storage accounts, but I think if you want to get the IDs from those storage accounts, you might need to do a range of 0 to length of storage copy -1. Hopefully. Wonder if I'm doing something wrong here. Probably. So let's take a look at this here. Length of storage array. I'm missing something here at the moment. Oh well. Yeah. I won't spend too much time troubleshooting on this right now, but basically how you do it is here's some storage IDs. So I do in range. I'm missing the in probably. In range 0 to length of the storage array, and this basically gets me the indexer of the storage account, and it gets the ID. And here I can just do anything I want from that storage account itself, which is pretty good. So I can get an array of those, all of those storage account gates. So one more thing about arrays here is that there is supposed to be support for decorators, and how they work is that you write batch size. For example, if you wanted to do 2 storage accounts at a time, so do 2, 2, 2, and 2 more. And you could also have a separate decorator here, which specifies how the copies done. So is it parallel or is it serialized? Let me check again. Yeah, still looking good. So if it's serialized, of course, some resources require it. But while this is found in the documentation of Bicep, I have not yet been able to get this to work. Perhaps I'm doing something wrong here, but it just doesn't want to build with this decorator at this very moment. But hopefully you won't be needing those anyway. It's quite rare to actually have to do anything with those. Then next up, let's take a look at the implicit depends on, which is one of the better things in Bicep. So you no longer need to kind of do a depends on field. And for that, let's create a app service plan. This could be app service plan or just something like my plan, whatever. We can do server forms here, and in it, let's do name. This would be something like my plan again. Kind, actually can't remember what's in kind, so I'll leave it out. Location can be the variable location we specified. SKU. This doesn't give me much of help here, but I do remember that they should be something like something like this for S1. And lastly, we do need some properties, I think. Or do I probably don't need any properties actually for this one, so let's leave them out. Yeah, I think that's it. Then we can do an app service. So my site, and this is sites. You can use the same API version here. And for this, you can do name. This needs to be unique, so I'll just add something here. We can give it a location. We can give it an system system assigned managed identity, like so. And then for properties, let's do something like server farm ID. This is at least required. So I can just get it from my plan.id again. And when I build this, I should be getting the depends on by default. So here's my website. And as we can see, it automatically gets the resource ID here, but it also creates depends on. So I don't need to specify it separately here, which is a really good thing and helps at least myself to not do so many errors when creating ARM templates for the first time. This doesn't mean that you cannot specify a depends on yourself though, but then you need to remember, I think, to specify all of them here. I'm not sure about that, but if there's something that you need to depend on and you can't do it like implicitly, you can just write it here yourself. And this can just be, let's see if we want to depend on storage account. So this is the first storage account we created. So let's see how this works. So it knows to get the ID here directly, and I did not need to specify the my plan again. So that's pretty cool. And as we can see, I don't need to do storage account.id here. I can just do storage account. So it kind of knows how this is supposed to be right there. All right, then next up, we have a key vault. So what I'm trying to show here is the child resource capability. So let's just create a key vault quickly here. This is vaults, and I can use that one. Then give it a name. something like that. Location can be the same. Then we can do properties, and here I do need access policies. So let's give our my site an access policy so it can read some secrets here. And how I do that is kind of similar to ARM, but I can just do my site dot identity dot principal ID. I don't need to do any functions here myself. I do permissions being secrets and get. And what I also do need here is tenant ID. So tenant ID I can get from the subscription function dot tenant ID. And lastly, I'm still missing something. It gives me an error. So we are missing an SKU and a tenant ID. So let's do tenant ID here. It's the same as we did earlier. And then SKU. And this, I can never remember how this works. But I think it's something like this. This is an A. There we go. That's the right way to do this. So now we have a key vault, and now we need a child resource for it. So secret. So for ARM templates, you have the resources array here for a separate resource. But to my knowledge, there's no way to do that in Bicep. So you would then need to just do a separate resource for this. So you would do secret. This could be something like storage key and secrets. And we can just take this here and do something like, scroll up a little bit, name. So as this is a child resource, and child resource always need resource type for the child and then the resource type for the parent. We need to do some string interpolation here, and here's how to do it in Bicep. So basically anything that's inside these brackets here, or braces, whatever, gets interpolated. So I could do something like key vault dot name, and then just add my storage / key, for example, or --. And in properties, we can just get a value for something. Let's do that in a second. But as we mentioned earlier, you can get the depends on here directly for the key vault name. And for this, we can do list keys. And we can see what do we actually need. A resource identifier or name. So for this, let's take the secondary key from our resource group or storage account array. So let's do storage copy, and the index of that storage account, we had 2, so let's take index 1, and this could be ID. Then we need the API version. We can also get that the same way, storage copy.1, and then we get the API version here at the top. And lastly, this I think already gets us the required secrets, but then I think it's keys in index1.value to get the primary key. Here you didn't get any intelligence, but actually most times if you do a reference function, it does actually provide you some intelligence, so you don't need to remember these yourself. But good. This should now generate us with a pretty good setup things. That's almost or a big part of the new features, so to say, of Bicep. But let's take a look at still for modules, CICD, and then decompilation. So in ARM templates, you have link templates, which is a separate ARM file that you call with the resources / deployments resource type. So this works pretty similarly, but with link templates, you always need to store your link templates in, let's say, a storage account with a SAS token. And modules help with that, so you no longer need to do that. So if you wanted to, any Bicep file is a module. And how that works is that let's just create a main file for it. Here example to call our storage.bicep. So main.bicep, and here I could just do module. So here's an example of how that works, but let's do it with this. So again, we need to give an identifier. Let's do storage module or storage one, let's say. And then we need to give a path to the storage account itself. Not the storage account, but the module file. So we get some intelligence here of where to use it. So this is just kind of relative to the file you are editing. Where is it, the module located? So like so. And then again, we could do a copy loop here or just give a object. And we need a name for this. So let's do, this could be something like storage one. And then we could do depends on scope and parameters again. So scope, here we could say something like resource group and give this a separate name. So this would deploy to a resource group named this, even though the default scope of a Bicep and ARM deployment is the resource group. You can still deploy to another resource group from that. But let's take this out for now and do parameters. So what's cool here is that if I don't have a default value for some value, so let's take this dev out here. And let's take this out also, like so. So Bicep knows what's in the module file. So it knows we need an env and a storage name, which are required properties. And it also gives them in the intelligence, like so. So this is pretty good. So you don't need to look at what's in it. So there's an abstraction from the user of your modules. So we could do storage name, give it something here, and env, same, do dev for example. And there's nothing to prevent you from doing this. So you have two modules, just give this different name. Of course, you probably need to give some different values here. Storage account names are unique. And we have some hard-coded values, so this wouldn't necessarily deploy. But how this looks, let's see. Let's change this to main.bicep. It does build, but this probably wouldn't deploy. But we get resources on the top level, and then we have Microsoft.resources/deployments things here, and they are just kind of nested here. So we have one of those and then a second one. So this kind of means that in link templates you have multiple files, but Bicep kind of builds it into one single file, which means that you can just send this file to Azure instead of pointing Azure to your other files, which does speed up development, at least for myself, a lot when I don't need to run some script every time I do a change to test if it actually works. Yeah, one more thing here in the modules part or in Bicep part in general, we can also do here target scope. So this could be management group, resource group, subscription, or tenant. So just like in ARM templates, you can specify it here where to deploy or where to can target for your first amount or top level deployment. So that's just one file there. Pretty simple. Then next up we had, let's see, probably CICD. So the Bicep repository, which I will be linking to soon, will have examples for GitHub Actions on how to do it. But my implementation for Azure DevOps is basically very similar to what's in untemplates, because basically I just built the Bicep file before I deploy. And the only thing that changes for myself is that I download the Bicep file from GitHub 0.3.1 and put it to my tools directory in Azure DevOps. And then I just build my Bicep file here. So in my artifacts, then I will have a ARM template, so a JSON file. Then I just point my unit tests to this location where it's built, publish my test results, and here's an example of how to deploy it. So this is just validation, but basically we have a main.json for my main.bicep in that same location. And I could just do some different deployment mode here to actually deploy the resources. So very simple, not too much changes here. And probably once you have verified that Azure DevOps agents that you run on have updated their PowerShell and AZ CLI, you could probably do that without even running this PowerShell script here. But as you can see, I'm using the older version of the Azure Resource Group deployment here also. So this probably doesn't support deploying Bicep directly. So, which is why I've just bolted this in here. So very simple to deploy there also. And lastly, decompilation. So let's try it. We already have main.json here, an ARM template that should work. But you might want to turn this into a Bicep template. So let's just do something like main2, that's fine. This will generate some errors, so don't be scared of those, but we can do something like this. So let's do main2.json. So what this does is it tries to generate Bicep files for you. But as the error says, it's best effort. There are no guaranteed mappings. But what it does is that it should generate kind of starter Bicep file. Let's check to see if it did anything right now. Well, for some reason it actually did not, because maybe I'm doing something wrong. No, decompilation does not support the copy property yet. So let's try with another file and actually remove the copy from this part. So there we go, and maybe hopefully I'm not pointing to the storage copy anywhere else here. So let's build this storage first. So do storage.bicep and then try to do, it always names them the same, so I need to rename, so storage2. So now it worked. So we went back into the storage2 or storage Bicep version. But as we can see, this is just a beginning. You will probably end up running into some errors, but usually this error message here provides you with a list of everything that you need to change. So I did have one example somewhere. Let's see. Yeah, I've closed it. So, but anyway, basically, this is something that you often need to change. So the identifier, there are often some resource ID functions that you might want to change into something like this.name or something like this.id instead of having the resource ID there, and so on. So it's not perfect, but it does work. So this will get you started with transferring into Bicep yourself. What else? I did have one more example. I have 5 minutes left here, so if you have any questions, please write them in the chat now, so I will answer them in just a minute. But here's just a ready-made example of how kind of full Bicep file would look like. So I often do something like having a global object which has everything that I have, kind of generic files or generic information, application name, tags, whatever inside this global object. Then I have some SQL stuff, web app SQL, SKU, and so on. Then I have a naming convention here generated as a variable. And I just pass this whole naming to my modules here. So every module knows the name of every other resource in my ARM templates or Bicep files. The whole deployment in that sense. Then I have my kind of modules here. I have an output of a resource group name. I try to place always my resource name outputs here in the top level and get them from the outputs of the module deployment. And this way I can just use these outputs in my deployment pipelines later on. So I can get it from the outputs of the ARM template and then just deploy my code to this specific function app, for example, without actually needing to do any kind of logic on the deployment pipeline on what the actual name is, or store it some way, whereas a variable otherwise. So the thing that deploys the infrastructure actually owns the infrastructure naming also. Other parts just ask it questions. But yeah, those were my demos. Let's take a look at some takeaways quickly, and then go to questions and other resources. So I think the syntax is quite simple. It's also much easier to use than ARM, in my opinion at least. It's also easier to test and develop with the module pattern, in my opinion at least. It's production ready, you freely test it out. It's easy to get started also. And the decompilation process helps you get started, so it's not perfect, but it works. Then lastly, links. So you will get these slides. These links are also in the description of the YouTube video right now, so you can take a look at them here. But the repository has a lot of documentation from all the expressions, for example. This ARM to Bicep is a good file to look at. So there's a list of how things are done in an ARM template, what does it look like in Bicep, and kind of best practices for that use. Then we have tutorials and sample templates. So the same repository has a 7-part tutorial you can go through. And we also have the sample files in this example folder. So these are kind of the same as the quick start ARM templates. I haven't compared them, but they have most of the same stuff here. And lastly, we have the playground. So this is something that you can try on the browser without installing anything. You get a Bicep file here and see what it is like in ARM templates. And if we take everything out, we can see that it generates just something basic. We can also take a look at the sample templates here in the playground and see how they work. And you can also copy a link and decompile your uploaded ARM templates if you want here. But I would just go with the VS Code part because this doesn't have any IntelliSense, and hopefully you understood from my examples on how useful the IntelliSense actually is when you are developing stuff with Bicep. Then lastly, actually, well, that was pretty much my stuff here. You can take a look at my blog. There's nothing on Bicep yet there, but hopefully in the future. But let's see if you have any questions in the chat right now. So, will ARM templates be gone at some point? I don't think so, because Bicep uses ARM templates kind of as the backend. So there's no reason to really remove the ARM templates, at least not now. as Teemu has mentioned, maybe in 5 years. But yeah, I agree. If you have any other questions, please write them in the chat. Now I'm waiting here for a couple of minutes. And while you are writing them, here's a link to the files. And I think that all the examples are in this repository, but most of them are. And you can take a look at the slides from there if you want. But that's pretty much it. There. Let's see if I have any other questions here at the top. Not yet. I will wait a couple more minutes here. But other than that, thank you all for joining. Sorry for the trouble with OBS. Seemingly restarting the whole thing seemed to work. And yes, the presentation will be available here in the YouTube, and also you can take a look at the links in the descriptions. And Yuri also asked, can you use the output of one module as input for another? I think you can, yes. I don't see any reason why you couldn't. The only thing that happens there is that you might need to, I'm not actually sure if you need to specify the depends on explicitly in that case for the module or not. But I suppose if you point to the outputs of module 1 in module 2 parameters, that should work. But you still need to pass it as a parameter to the other module there. All right. If there's no other questions, you can always find me on Twitter. Let me hide my face here somehow, maybe. Well, I'm not sure if I can actually do that right now. But you can find me on Twitter at Dr. Bushytop, and you can also message me on LinkedIn or whatever. Send me a connection and let's talk. But thank you.